In this example, we're going to determine the current through the inductor as a function of time when the circuit is closed, and then also again when the switch is opened back up again after reaching steady state. So in this particular problem, the inductor is not just in series with a resistor and a voltage supply, so we need to determine the Thevenin equivalent circuit across AB. So we would redraw our circuit and remove the inductor from the circuit. And as we do that, we can redraw our picture. And I have decided to combine the two resistors R2 and R3 together into one resistor because they are in parallel. So if I combine them in parallel, I get a value of 160 ohms. And then I have my other resistor here and my voltage supply. So the very first thing that we need to do is we need to find the Thevenin equivalent resistance, which means that we need to remove the voltage supply from the circuit and replace the voltage supply with a short and then see how the resistors are connected. So if I remove the voltage supply, I have a circuit that looks like the following. Where R1 and R total 1 are in parallel with one another. So I can combine those two resistors, which are in parallel, into an equivalent resistance. And when I combine those together, I get 96 ohms. And now I'm interested in knowing what the the resistance is across AB. And those two resistors are in series, so my Thevenin equivalent resistance is just going to be equal to 200 ohms. After I determine the Thevenin equivalent resistance, I need to go back to my circuit that has AB opened, and I need to determine what is the voltage across this open circuit. And if I figure out the voltage across AB when it's opened, that will tell me the Thevenin equivalent voltage. So when I go back to my original picture, I realize that the voltage across resistor 4 is just going to be 0 because there's no current running through that particular section. But when I look at the other loop, I see that there is current going through the loop because it's a complete circuit. And there are only 2 resistors and 1 voltage supply, so I can determine the current in that circuit is 100 volts over a total resistance of 400 ohms. 240 plus 160, and this gives me 0.25 amps. This will allow me to determine what the voltage is across each of those resistors. So the voltage across the total equivalent resistance of 160 is the current times the resistance, and that's going to give me 40 volts. And I could do the same thing for the other resistor, and that would give me 60 volts. I got a little ahead of myself. That will give me 60 volts. And of course, if those two are added together, they have to equal the voltage supply. So V1 is 60, and V total equivalent is 40 volts. Now I'm interested in knowing what is the voltage across AB, so I'm going to go ahead and label those polarities across AB. And now if I go around this loop, and I do the sum of the voltages, have to add up to 0, I can start and I go across AB, and I have a voltage VAB. And then as I go across the resistor, the 160 ohm resistor, it's a drop of 40. And as I go across R4, it's 0. It has to equal 0, so VAB, which is our Thevenin equivalent voltage, is equal to 40 volts.